Counting elements. Given an integer array, count how many elements x there are, such that x plus 1 is also an array. If there are duplicates in count them separately. So, in input, we have is equal to 1, 2, 3. Our output is equal to 2 because 1 plus 1 is 2, and 2 exists in this array. Then we go to the second element, 2, and 2 plus 1 is 3, and 3 exists in this array. But 3 plus 1 is 4, and 4 does not exist in this array. Therefore, only 1, 2. Our output is 2. So that's how many elements have element plus 1 in the array. If there's duplicates, for example, if there was a 1, 1, 2, 3, our output would be 3 because 1 would have 2 in the array. The second one would also have 2 in the array. And 2 would have 3 in the array. And for example, here you can see that there's no numbers counted because 1 plus 1 is 2, 2 does not exist, 3 plus 1 is 4, 4 does not exist, etc. Okay, so how are we going to code this? To code this, we're going to use a hash map. Basically, what we're going to do is we're going to run through this array once, and we're going to keep track of how many times each number is seen in the array. So for example, if we take a look at example 2, the key for the number 1 would be 2, the key for number 3 would be 2, and the key for number 5 would be 2, etc. because each of these are seen twice in this array. After we've counted up how many times each number has been seen in the array, now we want to see if x plus 1 of that key is in the array. So then we do a check afterwards to see if for each key, if that key plus 1. So if for 1 here, if 2 is in the array, and if 2 is in the array, then we'd add to the counter. Yeah, that would be our algorithm, and that would get our answer. So to do this, we're going to have a cur is equal 0 because that'll be our counter, and we're going to have tracker, which is our dictionary, which is a hash map, by the way, just in Python implementation. So for our array, for I in range length array, what we're going to do is actually I think we can just go through the array itself. I don't know if we need to do this. For I in array, if tracker of I, or if I is in tracker dot keys already, so because like if we've already seen I, then what we're going to do is we're going to do tracker of I plus equals to 1, right? We're going to make that value or that counter go up. Otherwise, what we're going to do is we're going to create it. So tracker of I is equal to 1. Okay. So now that we have everything counted up, so now we have everything counted up. Okay. Now what we can do is the second part. So check if x plus 1. Okay. For y in tracker dot keys, if y plus 1 is in tracker dot keys, we're going to add to cur the same amount of y. So basically, to get y, you do tracker y. So yeah. So if tracker is our hash map, then if we do tracker y, we're going into the key y, right? We're putting tracker, and in the key of y, how many times that key occur? We're getting the count, and we're adding that to cur. Yeah. And we would return cur. And that would be our answer. So this would be O of n. And since tracker would pretty much also pretty much just be the array plus the count, that would be, we call this m. So time complexity could be O of n plus m. Space complexity is O of n because we created a tracker or a hash map here. Yeah, so space complexity or extra space would be O of n. Now, before I end this video, I want to see if there's a better way to do this, because now I'm thinking about it. O of n plus m runtime complexity and O of n extra space is not amazing. Hey guys, when I make these videos, I'm trying to learn too. So this is me learning as well. This is not just, you know, like in a real interview, you know, you learn during the interview, right? So search with hash set. Oh, search with sorted array. N log n. So our hash set implementation would be, we'd create a hash set, which is equal to the set of array. So we take the array and we'd create a set, so no duplicates. Count would be 0. And then for x in array, if x plus 1 is in hash set. Oh. Yeah, no, that's probably better, honestly. So let's actually code that up right now. And I'm going to explain that while I'm doing it. Okay? So, if we want to check if for existence, which is what this problem is, when checking for existence, you want to use sets, okay? So we're going to do set is equal to a set of array, okay? And we're going to do for I in array, if I plus 1, so we could also have a cur, by the way. Cur would be equal to 0. And if I plus 1 is inside array, or is inside array set, then cur would just go up 1, because like each time. Yeah, that's smart. It's really smart. Then we could return cur, and that would be our answer. It's a great way to do it. O of n. It's still O of n space and time, but it's cleaner, looks better. And that's how you do it. That is how you do it.